All right, I think we're good. The reason I made it private was because I thought that would stop Chris from joining, but it stopped you from joining, so that didn't work. Mic check. Okay. So let's go through this thing. Projectile motion is so fun. All right, I think we're good. Oh, I've got no viewers. What happened? How did Chris get the link? Yeah, see, I have no idea. I don't know how he gets it. I feel like, yeah, actually, I have no idea, to be honest. Because it's not public. I have it unlisted, so, like, I don't know. And then he shares it with the class, and then there'll be like 10 people in here. All right. I guess pretty much all this stuff is irrelevant. I just thought it was interesting to note that it's not a HSC question, which is why the last part of it, I have done this, the last part of it's a little bit strange. I didn't really know what to do when I was doing it, but we'll go through it. So essentially, this bloke's on a snowboard. He jumps up, and then it literally says that he does a trick. Yeah, performs various tricks, and then kind of comes down and lands on a slope. So I guess this is just like a normal projectile motion question, but you know, you just kind of forget that that exists, and that's not the ground. Like the ground kind of goes downwards. So if I want to find the angle, that's just this part. So if I want to find the angle, the speed, and the max height, all of that stuff, I kind of ignore that this even exists. And I just pretend that I'm only looking at this part. It's the last part of the question where it says the time spent in the air. That is kind of the, I guess, the part that includes this part because he's still in the air when he's down here. So pretty much for these three, I'm just going to ignore this and just work on this. So if I want to find the angle, one other thing is it gives me the position vector. It doesn't actually give me the velocity vector. So that's something I probably need to find as well. So what question is this? 12. I've got it in the top corner. 12. Is it I or A? A this time. So the Victorian papers must use A because like the other ones have I's, the HSC. How interesting. Anyway, okay, let's position vector. I feel like writing the tilde. Yeah, screw it. RT. I like writing it like column vectors. 6t 0.01 t squared. T cubed, is it? 6 root 3 t 4.9. And it's nice that they've given us the formulas. They could have made us derive them, but they haven't, which is quite kind. Do you let x? Yeah. How did you know that? Because I didn't know that. That's really smart. I thought that the way I kind of thought about it was I knew I'd have to do something with like minus x, but I thought it was going to be, I don't know, I had in my head that this was a t, and I was trying to set this equal to, no, sorry, the like vt, but the j component equal to minus t, if that made any sense. But you're actually, yeah, you're actually correct. I want to show you a couple of things about this question too. And that's definitely the band 6 part I'd be assuming. Okay, my R's and V's look identical. So V, T, bit of calculus, 6 minus 0.01, no, 0.03 T squared, 6 root 3 minus 9.8 T plus 0.03 T squared. Okay, so that's my velocity vector. What am I trying to find? The angle at, now that would be at time 0, so then I'd need to go, it's just intuitive. So at time 0, that's going to be 6 and 6 root 3. So if I then find that angle, tan theta is going to be 6 root 3 on 6, which is just root 3. That means theta equals, is it pi on 6 or pi on 3? I always forget. Pi on 3, 60 degrees. Okay. Yeah, it makes sense. I don't know. I think I get confused with the notation of vectors, but it does make sense that like you're thinking of this obviously as x and that as y. It's a clever question. Find the speed. Okay, so it's interesting to note that the first part's worth 2 marks and the second part's worth 1 mark, and it's kind of because the first part you have to find the velocity vector, and the second part you've already got the velocity vector. Part 3, yeah, thanks. So the speed is going to be magnitude of v times 0 because it wants the speed when they leave the jump, so the initial speed. Normally they give you the initial speed in a question like this, but oh well. 6 squared plus 6 squared times 3, 6 root 3 all squared. That's the square root of 144, which is 12. It's in, so it says distance measured in meters and time in seconds. So meters per second. Sometimes you'll see it meters second, this one. Okay, find the maximum height. This has been easy so far. Maximum height. So maximum height occurs when y, so j, I guess. So when the speed of j reaches 0, so it's like when they tip over. So that means vj of t, that's just this part here. Let's copy that. Paste. So it's when that equals 0. So it seems as though I've got a bit of a quadratic here, pretty disgusting one, but still a quadratic. Minus b plus or minus the square root of b squared minus 4 times 0.03 times that, all on 2 times 0. I'm not going to obviously do this in front of you, but it's, so I thought this was interesting too, because normally you get like a positive and a negative. 325.6 and 1.06. Yeah, so I thought it was kind of interesting with this. So this is saying 325 seconds, which obviously makes 0 sense because that means he's in the air for like 6 minutes or something, which is pretty insane. That means the jump would have to have been, I'd love to calculate how high the jump would have been for him to be in the air for 6 minutes, but I'm assuming the 1 second makes a little bit more sense. So we'll let t equal 1.06. Now it actually wants the height. I've only got the time at which the max height occurs, so then I need to substitute that into the position vector. So r of 1.06. Now I only want the j component because I want to know how high he is. There's a lot of little mistakes to be made here, I think. So yeah, 6 root 3 minus 9.8. Oh, I forgot a t there. 1.06. That's not 9.8, that's 4.9. 4.9 t squared. Plus 1. No. And that's equal to, what did I get? 5.5. And again, I just checked my answers obviously make sense. I'm curious what this graph looks like. If that's 325, that's pretty, yeah. Okay, so 5 meters in the air, and he was in the air for about a second. So that kind of makes sense, I guess. All right, so the last one, you're completely right. So we let y equal minus x, and I'm going to put this in the middle. Obviously my y is, where is it? Let me just copy and paste this whole thing. Copy. So that, no, y. Y, got my room. Yeah, so that's pretty much what you were saying. And I guess a cool thing is that you might look at this and be like, yuck, I've got to deal with a cubic, but you don't, because they're going to disappear. And when I make that a minus and move it over, I'm going to end up with 6 plus 6 root 3 t minus 4.9 t squared equals 0. And so then, at this stage, you'd probably factorize, and then you'd come up with the fact that obviously t equals 0, but that's just giving me the solution where, like this, where he's still on the ramp. So I don't really care about that. So I can be heaps dangerous here and just be like, goodbye, goodbye. So then if I move the 4.9t over, and I leave this, then I've got t equals 6 plus 6 root 3. This is a show that question, isn't it? 4.9. It is. Okay, so I just times everything by 10. So 60 plus 60 root 3. Oh, they factorized it. Did they yeah. It's pretty obvious where we go from there. 49. I kind of want to work out what that is, to be honest. I haven't done this, but I'm curious. Root 3 plus 1, 49. So that's 3.3 seconds. Okay, so this whole thing kind of makes sense. So he's like, what was the speed? What did we come up with for the speed? 12 meters per second. So he jumps at 12 meters per second. After 1 second, 1.06 seconds, he ends up at his max height. And then another 2 seconds, so this is 3.34. That's when he lands on the ramp. So I guess that kind of makes sense. Another cool question. I really like projectile motion questions. Okay, so like I was saying, I didn't really know. Like I understood that I needed to have, I guess, the y equals minus x, but I was trying to think of it in terms of t, so I wasn't quite doing it correctly. But I looked up. So this is actually 2019's HSC, and they have like an almost identical question. So it's the exact same thing. He takes off here, but they actually give you the y equals minus x, and then they give you, they don't give it to you in terms of vectors because vectors wasn't part of the course in 2019. So they gave you like parametric equations, so x and y. And I don't know why this is 2 marks, but it's literally just, maybe there's a little bit of algebra involved, but it's literally just substituting into y equals minus x. So I guess it's the exact same question, except they've written it, like if you, I've got both of them on the screen. Like if you look at them, they're just obviously written slightly different. I think that's kind of interesting. I'll show you the solution. So, they do write it in terms of vectors. Oh, no, they don't. No, they don't. Scrap that. Oh, that's II. So that's this one. So y equals minus x, and they just substitute it. They've got 2 values. The t equals 0 doesn't make any sense because that's the start. And then they want, what did the question want? It didn't want the time, it wanted the distance. Ours wanted the time. So they had to substitute it back. Maybe that's why it's worth 2 marks. But then the second question I thought was kind of interesting. They said, what's the size of the acute angle that the path of the particle makes with the sloping plane as the particle hits? So they don't even consider this to be a snowboarder. They're just calling it a particle. And they're kind of saying that what's the angle that when the person lands, what's the acute angle that they make? So what's this angle? I think that's kind of an interesting question. Oh, I just got rid of it. Oh, screw it. So they make like a little right angle triangle here. And just trying to read the solution. I think it's a kind of interesting question. I have to look through this. Where did they get that 18 from? That's how far across. Yeah, okay. But that's a 3-mark question. Okay, because this one, they didn't have to differentiate in the last question. So they had to find the derivatives first. So that they could find, the last question didn't require the derivatives at all, but our one, yeah, okay. Our part D didn't require derivatives either. So that's the first mark. I don't know why my font's all stuffed up when I open up a thing in Google Chrome. Finds the slope of the path. Yeah, I think that's a pretty interesting question. And then when I was looking through this, oh damn it, I wish I didn't close it. Oh, I guess you're going to see my history. Yeah, so this was the HSC question, obviously. And then when I kept scrolling down, I found this, which is the next question we're going to do anyway. So that's this one, 14C. So there's essentially like two Band 6 questions right next to each other 2 years ago. That's kind of interesting. But if you look up, I reckon that's a perfectly achievable mathematical induction question. I haven't really looked at this hyperbola one, but this is kind of cool. Newton's method. I don't know if you've heard of that before, but I learned that at uni. I never learned that at school. So that used to be part of the course. Obviously, it's not anymore. Anyway, let's go through this one because this one's kind of weird. So, have I got it up there? Yep. Okay. They're not worth many marks. Like the whole thing's worth 5, but the diagram shows two curves. It's got sine x and sine x minus alpha. It tells you that, or plus k, it tells you that alpha is between 0 and pi, and it tells you that there's a random point on there where there's a common tangent. So this point is kind of where they cross, and it's told you that they have a common, gradient, I guess. And this is less than pi on 2, so it's less than 90 degrees, whereas the other one was less than 180. So it's basically saying, explain why this and this is true, which is, well, I guess the only real way you could think about comparing them is the fact that they have a common tangent. So you should be able to use these two. If you just think about this, if I just have these two and I differentiated each of those, I'm going to end up with this and this. When I substitute my point in there, I should be able to make an argument for the gradient of the tangent being identical because they've told me that. So that's kind of how I'm going to get this 1 mark. I reckon that's a cool question. So 13, and we're calling it I. Yep. Okay, so I'm going to because look, they say y is this and y is that. So let's just call them y1 and y2. So y1 is sine x. y2 is sine x. Oh, are they using x or? Yeah, x minus alpha plus k. If I differentiate each of these, so dy1 dx, notice I'm not writing y1 dash cos x, dy2 dx is cos x minus alpha. Okay, and at x equals x0, this is equal to cos x0, and this is equal to cos x0 minus alpha. Good so far. And since tangent is common, and that was given information, therefore cos equals cos, and that's enough of an argument because they pretty much give you all the information for that question. Okay, 2. Where are we? Show that sine is equal to minus sine. I feel like this is the more confusing part, and it's because it's not really obvious. Like, unless you kind of put values in for, unless you put values in for alpha and x0, it's kind of hard to make sense of, especially given like the way the graph's drawn, I guess. So I like relating things to my unit circle. I just guess you got to think about, so where's my thing? Where's x0? Well, that's between 0 and pi on 2. So sorry, I'm just looking up here. So that means it's somewhere between 0 and 90. So that means it's, I don't know, in here somewhere. And then if you look at, so I guess in the question I've got x0 minus alpha, you kind of got to think to yourself, where's that going to be sitting? And there's two places it could be sitting. It could be sitting in, it depends how big alpha is, right? Like if it was 1/8, if it was, because, oh my God, let me just write it. X0 is between 0 and pi on 2. And alpha, I'm going to use extension 2 notation, is here. So this has to be within here, right? Now, if I take away alpha, if this was less than 90, then x, so this minus this would be in here somewhere. But if it was more than 90, it would be here somewhere. So there's kind of two spots for x0 minus alpha to be. So it could be here or it could be here. So x0 minus alpha or x0 minus, I hope that makes sense. What if Claudia join us there? Whatever. Okay. And this is kind of why I don't really like this argument, because it's kind of implied in my drawing that I'm focusing on this one because I am suggesting that alpha is bigger than x0, even though it doesn't have to be, but anyway. Okay, so all stations to central. So in here, sine x0 is going to be positive, and here, sine, what am I doing? X minus alpha is negative. And if I wanted these to obviously be equal, which means obviously I wouldn't be looking at this one, I'd be looking at this one so that my acute angles are the same. So let me just get rid of that because that's confusing. The only way that this is going to be possible for those two to be equal is if these two are equal, but this has to be the negative because obviously sine's not positive there. I think this is a terrible argument, but I couldn't think of another way to argue it. I did look at the solution, and maybe let's look at this solution. That was here's the argument that HSC makes. I don't know if you can still, no you can't. Can you see that? Yeah, you don't get it. Okay, so here's the argument that HSC makes. They start with what the last question gave. Then they, I guess, just start with sine squared and then make it look like how do you explain it? Like they just turn it into cos and make it look like sine squared x0 minus alpha. And this is what I was saying before. I essentially have plus minus. So maybe I should have made that a little bit clearer. If I put back I put this back, I essentially have plus minus. Like it could be both. These could both, I guess, be equal. Now, if k is greater than 0, which is what the question gives you up here, it tells you k is greater than 0. Greater than, I don't really get that part, to be honest. I don't know. I can't think of a better way to argue that. If k was greater than 0, that means I don't know. I can't think of a better way to argue that, to be honest. I'll show you the last part and we'll come back to this because the last part makes a little bit more sense to me. Okay. So the last part says if it's otherwise find k in terms of alpha. So I don't think that's too bad, but when it says in terms of alpha, I think that's kind of annoying. Because it says hence, it kind of implies that you're going to use the previous part. Yeah. It's kind of, the reason it says otherwise is so that you have an opportunity to do it however you want, I guess, but this hence is kind of implying I need the last part. Okay. I do know that these two things equal each other at a point. So they equal each other when y1 equals y2. So that was sine xo equaled sine x, that's a strange x, xo minus alpha plus k. Now, that's kind of what I start with, and I have a way to find k, but using the last part, he gave us this, so I can swap this out for this, which looks like this, so I can kind of join them. I'm working the wrong time. No, that was a long time. Thank you. Anyway, I started with this. This is what I was given in the question. I want to find k, so I can move this over, but that's not going to allow me to, I guess, find it in terms of alpha. So what I'm going to do is I'm going to swap this out for this, so using this statement, and now that's nice because I can kind of combine the two terms. So I'm going to swap this out for minus sine xo plus k. Then I've got 2 sine xo equals k, and that's it. But my problem is I don't have this in terms of alpha anymore. I have it in terms of xo. So I need to get it in terms of alpha. Now that was from 2. If I just worked on this, let me start with that. Sine xo. You can tell I'm not very good at trigonometry. Okay, if I just start on that, I want to be able to, so yeah, I haven't really, like I used this part here, but I kind of want to use it again because I want to swap out x0 for something to do with alpha. Okay, I think that's the goal. Like the goal is to get rid of my xo and make it look like an alpha. And this is the nicest statement. I mean, you could use, where's the other one? I could use this. Oh yeah, why can't I just use this? This is why this confuses me. Anyway, I'm going to use this. So this minus is kind of annoying. I want to just be able to go see you later. This minus is going to annoy me. Oh, okay. I know the reason I don't use cos is because I'm in the wrong. Okay, I've got it. I just figured it out. The reason I don't use cos is because these two are defined in here, and they're both positive, whereas this is kind of confusing because I'm working here. That's my line of thinking. I don't know if that's entirely correct. I need to get rid of this minus. I know that sine is, can't remember if it's even or odd, but I know that it's allowing me to do this. Okay, so that means x, why do I keep drawing x's like that? Xo equals minus xo minus alpha. If I'd done that with this, I would have just ended up with the statement this equals 0. Can you see that? Like they would have just gone and would just had that equals, like doesn't make any sense. So now I've got, now I've got 2 of these equals alpha. So then I can put that here. K equals 2 sine. Xo equals alpha on 2. And that's k in terms of alpha. I feel like it's a very confusing question. Probably the reason why it's 14C in the extension 2 test, extension 1 test. Let's see how they did it. Okay. So they started with that. Then they drew this picture that looks like crab. They've said that, okay, they've made the comparison between these two and determined that this, in order for this to be true, that means it has to be sitting in either, where's pi on 2 to minus pi? Oh, they found the the quadrant that it's defined, that this is defined in, for these two statements to make sense. So minus pi on 2, minus pi on 2, x minus, I keep drawing them like that. So that's between here and where's minus pi? Here. So between pi on 2, how does that make any sense? Minus pi. So from pi on 2, I can go around all stations. Cos. What do they have? They had cos equals cos. They had sine equals minus sine. Is that what they had? Take it easy, Tuesday thing is done. Yeah, they had this. So how have they determined? Oh, they've just grabbed this and just taken away. I don't even know. This is. That means I'm working here. Cos equals. Okay, this statement makes sense because they could just be both minus. This statement doesn't make sense because they could be plus and minus. If I was doing this test, I'd never get this question right. But it is a very last question. Shows that equals. Oh, well, you would have gotten 1 mark to get from here, so that's kind of nice, I guess. Bit of work to get to the next part. Are you up to date with all your work? Like, what's your Tuesday going to be? Are you going to go on the well-being tab? I don't like arguments that bring in a squared out of nowhere. I find that very confusing, which is why I tried to do it a different way, more intuitive, more like this kind of way. But I don't know, I can't make sense of the plus minus and what the positive k does to it. I have a chemistry assignment, Jimmo. Ah, well, that gives you a day to do that, I guess. I got the list for my advanced class next year, and oh my god, they look awesome. It's going to be a class full of geniuses. I can't wait. I don't think anyone's picked extension 2, so I think you're going to be by yourself. I don't know. I'd like to do more. I'd like to do more questions, but I'm kind of running out. I've only got, so I'm not going to go through this one today, but I've only got, where is it? I won't go through this one today, but after that I've only got this. This is a fun question. I like these questions. That's not a fun question. That's definitely not a fun question. And these, and these, and that's it. I've not even looked at these. I feel like these are going to get harder and harder. Yeah, look, that's an extension 2 question. Yeah, I don't know. But I think that'll do me for today because my brain's a little bit fried after that trig question. This bloody thing. The first two made sense to me. This one doesn't. No, this one didn't make sense. I don't know. But I do like this question. I do like that you figured out that you had to do the y equals minus x. That's a good start. I don't know what a snowboardy is, but whatever. Okay, well, if you're happy to do it Thursday again and every other Tuesday, then I'm happy. But if it gets to the point where I run out of questions, I might just go find like the hardest questions in Cambridge and see how we go with those. Or we could look at extension 2. I don't care. I don't know if I'm allowed to do that, but I don't know. All right.